again, this is going to be the format of what your properties test will look like. Honestly, this will probably be exactly it. I might mix some of these up just to where you're not memorizing. Please don't memorize this. Just memorize where all the trues and falses or yeses and nos are. But actually know the properties and know why they're what they are. Let's go down through here and let's start with parallelograms. Let me draw one. And this is the same thing we went over yesterday. Let's go all the different properties of a parallelogram. Get your name cards. And go through these. Harley. Yes or no? We'll do three at a time. In a parallelogram, are both pairs of opposite sides parallel? Both pairs of opposite sides, meaning top and bottom is parallel, left and right. Is that true, Harley? Yes. Harley, are both pairs of opposite sides congruent? Yes. And are both pairs of opposite angles congruent? There we go. Next three. Trevor. Consecutive angles supplementary. This is your consecutive angles. Are these supplementary? These are supplementary? Yes. Do the diagonals bisect each other? Yes. And are the diagonals congruent? No. Let's go ahead and take care of that, though. Peyton, do you remember which shape that you do have congruent diagonals? A square does have congruent diagonals, so we can go ahead, if you want to go ahead and knock that one out. Yes. And there's one other one. That is a parallelogram. If you actually, here's your diagonals. And you see there, that one's fairly long and this one's pretty short. So no, the diagonals won't be congruent. But Peyton, see if you can picture. Make this diagonal a little bit longer by straightening this out. As you're straightening this out, also shorten this. Keep it a parallelogram. What would it turn into whenever you had congruent diagonals? It would be a rectangle. Good job. So a square and a rectangle, yeah, the diagonals are congruent there. I'm kind of skipping around now. Trey, let's go back again here. Are the diagonals perpendicular? No, not in a parallelogram, but do these look perpendicular? They do, don't they? There is a reason that these do kind of look perpendicular. It's because this parallelogram is nearly a special type parallelogram. Can anybody tell me what kind it nearly is? A rhombus. That's nearly a rhombus. And in a rhombus, you've got equal sides. And these, I actually drew this to where the sides are nearly equal. If you do have a rhombus, the diagonals would be perpendicular, yes. Sabrina here, yeah. Sabrina, what about, let's go back here. In a parallelogram, only one pair of opposite sides are parallel. Well, we've already took care of that. Sabrina, what do you think? Is only one pair parallel? No. It's two pairs. Only one pair of congruent sides? No. Do we have four right angles? No. On to rectangles. Dylan Davis. Two pairs of opposite parallel sides? Yes. Both pairs of opposite sides are also congruent? Yes. And both pairs of opposite angles are also congruent? Yes. And y'all call out the answer so we can go through them quick. Consecutive angles supplementary. Oh, we're on rectangle now. Okay, here we go. So now a rectangle. Consecutive angles, are they supplementary? Anybody? Yes. Do the diagonals bisect each other? Yes. Are the diagonals perpendicular? No. Okay, and you can see that if we drew them. If that were a diagonal. But the diagonals will not be perpendicular. Now, again, if you squeeze it together to create diagonals that were perpendicular, you'd actually have a different shape. There is a special rectangle where you do have diagonals that are perpendicular. Only one pair of opposite sides that are parallel. We know these are no, because up here we said there was two pairs. 4 right angles, yes. Next one, let's go to a rhombus. In a rhombus, both pair of opposite sides parallel. Yes. Both pairs congruent. Yes. Both pairs of opposite angles congruent. Yes. Consecutive angles supplementary. Yes. Diagonals bisect each other. Yes, because it's a parallelogram. Diagonals are congruent. Now look how long that one is. Look how short that one is now. Only one pair of opposite sides parallel. Again, we know no and no there because we said up here there's 2 pairs and there are not 4 right angles. Something to point out, guys. Both pairs of opposite sides parallel. This one, both pairs of opposite sides congruent. Both pairs of opposite angles congruent. Consecutive angles supplementary. Diagonals bisect each other. Somebody tell me something special about those 5 characteristics. Those are the characteristics of a parallelogram. So since, you see all the yeses, since a rectangle is a parallelogram, a rhombus is a parallelogram, and a square is a parallelogram, you know that all 5 of those first ones are going to be yeses. They're all parallelograms. We are dealing with a square now. Are the diagonals in a square perpendicular? Yes, they are. You don't have 1 pair, you have 2 pairs. Or do you have 4 right angles? Yes. There's all the properties of a square. Non-isosceles trapezoids. Make it non-isosceles, try to. Both pairs of opposite sides parallel. False. No. Both pairs of opposite sides congruent. No. Actually, neither pair of opposite sides will be congruent in a non-isosceles trapezoid. Both pairs of opposite angles congruent. No. Consecutive angles supplementary. Now, this is the one I need to point out. I'm going to give it a yes. Because these 2 consecutive angles are supplementary, these 2 consecutive angles are supplementary. I'm going to give it a yes. You've just got to be careful about which consecutive angles you're talking about because these 2 consecutive angles, no, are not supplementary. Because these 2 lines are not parallel. But since you have parallel here and here, I will say that these consecutive and these consecutive will be supplementary, so I'm going to give that a yes. And so on tomorrow's test, be cautious of that one. The diagonals bisect each other, no. Diagonals are congruent, no. Unless it's, we'll get to it in a second. Diagonals perpendicular, no. Only one side, or only 1 pair of opposite sides that are parallel, yes. Only 1 pair of congruent sides, no. 4 right angles, no. Now, isosceles trapezoid. Here we see an isosceles trapezoid. Both pairs of opposite sides parallel, no. Both pairs of opposite sides congruent, no. Both pairs of opposite angles congruent, no. Consecutive angles supplementary, yes again, because when I say consecutive, these will be supplementary. Diagonals bisect each other. What about that one? Do the diagonals bisect each other? No. Are the diagonals congruent? Yes, they are. That's the one that kind of scares me. Diagonals will not be perpendicular. Only 1 pair of opposite sides are parallel. Yes, they are. Only 1 pair of congruent sides. Yes, they are. And there they are. Left side, right side. That's what makes it isosceles. And it has 4 right angles. No. The other thing, and I wished I could list it somehow. You will have 2 sets. You'll have 2 sets of congruent angles. These will be congruent, and these will be congruent. So be cautious of how I word maybe this one. Because I might, instead of saying both angles, or both pairs of opposite angles are congruent, I might say 2 sets of congruent angles. Now, if I'd have said here there are 2 sets of congruent angles, that would have been a yes because there are 2 sets of congruent angles. Okay, they're not opposite of each other, but they are congruent. Okay, and the last one, a kite. Let me clear all these out down here. In a kite, both pairs of opposite sides are parallel. No, you actually have no parallel lines. Both pairs of opposite sides are congruent. No. Both pairs of opposite angles are congruent. That is also a no. Consecutive angles are supplementary. These are consecutive. These are not parallel. They will not be supplementary, or that would make them parallel. Diagonals bisect each other. No. You can see here that now actually this diagonal does bisect that one. Cuts it in half, but they don't bisect each other, so I'll give that a no. Diagonals are congruent. No. Diagonals are perpendicular. What do you think? Yes, they are. Only one pair of opposite sides parallel. No. Only one pair of congruent sides. Only one pair of congruent sides. No. There's two pair of congruent sides, right? Had I reworded this too? What if I'd said instead of both pairs of opposite sides are congruent, if I say there are two pairs of congruent sides, that would be a yes. These are congruent. These are congruent. If I put there two pairs of congruent sides, that would be a yes. 4 right angles, no. Okay, on your test review, let's go through your true and false first. Number 1 says the angles in a quadrilateral will always add up to 400 degrees. True, false? False. They'll always add up to 360. Thank you. Number 2, the diagonals of a rhombus are congruent. True, false? False. The diagonals of a what shape are congruent? Rectangle. Let's fix it another way. So the diagonals of a rectangle are congruent. The diagonals of a square are congruent. The diagonals of a rhombus are what? Perpendicular. Thank you. Number 3, the diagonals of a rectangle bisect each other. That is actually true because a rectangle is a parallelogram. That's going to be true. Number 4, all 4 sides of a rhombus are congruent. True. That's what makes it a rhombus. Number 5, a diagonal drawn and a rhombus will divide it into 2 congruent triangles. That is true. What if I change that? What if I put 2 diagonals drawn in a rhombus? Let's look at that. Let me find rhombus. If you draw a single diagonal, drawn will actually divide it into 2 triangles, yes. Not only 2 triangles, 2 congruent triangles, but actually 2 congruent isosceles triangles. If you draw both diagonals, that's a right angle. The diagonals are not congruent, but they do bisect each other. And if you look at all 4 of those triangles, look at the tick marks. You have 1, 2, and 3 tick marks on all 4. By side, all 4 of those triangles would be congruent. Number 6, the sum of the angles of a dodecagon, 1800 degrees. What y'all get on that one? True. Here's how you'd work that one. It's got 12 sides, which means it has 10 triangles. 10 180s, which is 1800. Good. Each angle of a regular pentagon will always add up to 112. Anybody get that one? False. Okay, pentagon, 5 sides, 3 triangles, 540 total degrees. Since there were 5 sides, there's also going to be 5 angles, which gives you a total of, does anybody have it still written down? 108. Each of them would equal 108, so it was close. The exterior angles of an 18-sided figure will add up to 360 degrees. True. Any shape, and again, that's our best friend, any shape has exterior angles that add up to 360. Whether it has 30 sides, 50 sides, 100 sides, exterior angles will always add up to 360. Let's do some math on that one. If it has 18 sides, 360 total degrees, can anybody tell me how big each exterior angle is going to be? 20 degrees, which means you can do a little bit more math in 160 degrees. That's a whole lot faster than the other math that we worked at. Each interior angle, if it's regular, would add up to would be 160. Much faster. The diagonals of number 9. The diagonals in a square are congruent. They bisect each other and they are perpendicular. True. Number 10. Opposite sides of a parallelogram are always parallel, but they are not always congruent. False. They are always congruent as well. Number 11. The ratio of the angle measures in a quadrilateral are 2 to 5 to 5 to 6. 2 to 5 to 5 to 6. There's your 4 angles. Since it is a quadrilateral, they should always add up to what? 360. We solve the equation. 12, 18x is 360, and you should get x is 20. The 4 angles, therefore, would be 40, 100, 100, and 120. What is the measure of the smallest angle? 40 degrees. Number 12, what is the length of the rhombus below? What is the side length of the rhombus? And a lot of people's going, but they don't tell you which side it's asking about. Garrett, what's true about the sides? Is he not here? Overlooking them. Austin, what's true about the sides of a rhombus? They're all congruent. It doesn't matter which one they're asking for. So you can find A, you can find B. It doesn't really matter there which one you find. Let's find A. 5A plus 4 equals 3A plus 8. Help me solve that, Taylor. Move all my A's to the left. How many do I have? And what's it going to equal? Move my 4 to the right. So A must be 2. We plug it in here or we plug it in here. You get 10 plus 4, which is 14. You get 6 plus 8, which is also 14. The side length is 14. So your A value is 2. I'm guessing your B value is probably 4. It is, if you worked it that way, and you get 14 regardless. Notice again, they didn't ask you for A or B, they asked you for the side length. Number 13. What is the intersection point of the diagonals of a parallelogram with the following vertices? Diagonals of a parallelogram. Parallelogram, diagonals. What's true about them? Colby, not in here. Ian. When you have a parallelogram, what's true about the diagonals? They bisect each other. Since they bisect each other, here's the formula you're going to want. Midpoint. They cut each other in half, so you're looking for what is the midpoint of each line segment. And if you need to graph it just to take a look at it, that's fine. Here they are. Let me give me an XY axis. You have the points negative 2, 4, 3, 5, 1, 2, 3, 1, 2, 3, 4, 5, 2, negative 3, and negative 3, 1, 2, 3, 1, 2, 3, 4. You're looking for the midpoint of either this line segment or this line segment. You could draw it if you want to and see where they cross. That's one method of doing it. Looks like it's going to cross like at 0, 0. Is that an answer choice? No, it's not. So you can't really tell sometimes by your drawing. So let's do this. You have, this is the point negative 2, 4. This is the point 2, negative 3. Midpoint. To find the midpoint, you add your x's and divide by 2. You add your y's and divide by 2. 0 divided by 2 is 0. 1 divided by 2 is a half. So that would be B, 0, 0.5. Number 14. In rectangle PQRS. I always like to draw it. I don't have a very good imagination. In rectangle PQRS, it says diagonals PR and QS intersect at T. PR, QS intersect at T. If PS is 180, I guess we can go ahead and say that this is also 180. PR is 200. How can we label that? The distance from here to here, let's just do it like this. This would be 100 and 100, right? The diagonals do bisect each other. And the diagonals are congruent since you're talking about a rectangle. So there's you a lot of information there. 100, 100. What's the length of QT? Just found it, 100. Now, something else I could ask you to do on this problem, actually a couple of other things. Let's discuss it just in case I change this problem, because more likely this is not your test, but your test will look similar to it. If I ask you for this length, how do you find it? 2 words? Pythagorean theorem. You're given that this is 180, you're given that this diagonal is 200, and you're looking for this side length, which is x. You would do x squared plus 180 squared equals 200 squared. Again, word of advice, shrink this down before you do that. Let me draw it again. Over here to the sides, you have 180, you have x and 200. Shrink it. What could we shrink it by a factor of? 10 would work. Actually, one bigger. 20 would work. Let's shrink it by a factor of 20. And once we find our answer, we'll blow it up by a factor of 20. That's going to be a whole lot easier. So you have x squared plus 81 equals 100. Subtract the 81, x squared is 19, so x is root 19. So therefore, since we shrunk it, this is root 19. We shrunk it by a factor of 20. Let's blow it up by a factor of 20 now, and you'll get 20 root 19. If they ask you to find that. Any questions on how I did that? Much faster, much easier to use the smaller numbers. Something else that I might ask you to do is I could ask you for the angles in there. I could ask you for this angle. More than likely, I wouldn't do that angle because you're going to have to use law of sines or law of cosines. I'm not as interested in you knowing law of sines and law of cosines as I am for you to know SOHCAHTOA. Let's say that I ask you for this angle here. We see the right triangle that I've outlined in black here. I know the opposite side, this is, let's call it y. The opposite side of that angle is 180. The hypotenuse is 200. Opposite the hypotenuse is a SAW, S-O-H, some old hippie. That's a sine problem. You could say the sine of your angle is equal to opposite over hypotenuse. And to find out what that angle is, you simply move sine over, you're done. So you would type into your calculator the inverse sine of 180 over 200. So y is about, let's see, 180 over 200. Yeah, that's kind of warped. It's not drawn to scale. So 64 degrees. Now, with knowing that that's 64, really you know everything else. Even if I ask you for this angle, you really don't have to find it, because if you know this is 64, then you know that this is 64. Everybody sees a Z, right? This is a rectangle, so that makes this 26 and 26. It makes this 26 and 26 as well. 64 here. 128. You see the small triangle here, 128 subtracted, I think you get 52 degrees, 52 degrees, and that would be 128 here. 52, yeah, that's right. So with finding one angle, really, pretty much you have all of them. Okay. Next problem, this is number 15. What is the most precise name for the quadrilateral of these vertices? We're asked for the most precise name here. First off, let's see, is it a parallelogram? Because we start with the most basic, well, it's a quadrilateral, we know that. Now, is it a parallelogram? There's a few different ways we can test to see if it's a parallelogram. The easiest way is probably check slopes. If opposite sides are parallel, by definition, it's a parallelogram. Slope here, you've got a rise of -2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So -2 over 9. Let's check this one. You have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Opposite slopes there are congruent, so that's parallel. Question, if I stop there and that's all that's true about it, can I say it's parallelogram? No. Could I say It's a different shape. What shape would it be right now? Trapezoid. It is at least a trapezoid. And you know what? You could check slope here and slope here, but you don't have to. I know this is a parallelogram already. Anybody tell me why? Opposite sides are parallel. Anybody know anything else that's true about the opposite sides? They're also congruent. For this reason, you could draw yourself a little right triangle here and a little right triangle here. Guys, it's 2 and 9. If you want to find this distance and this distance, you would do so by using Pythagorean theorem. You've got a length of 2, a length of 9, a length of 2, a length of 9. It's going to be the same thing. One of your conditions says if opposite sides are both parallel and congruent, it is a parallelogram. So really, you don't even have to check this one. It's going to be parallel. So we have a parallelogram so far. Now let's check. Let's go a step further. Is it a rectangle? Don't think it's going to be a rectangle. I don't know. I have just this bad feeling that this is not a rectangle. You can check it if it were a rectangle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Slope is 6 over 7. I'll go ahead and tell you this slope is also 6 over 7. If it were a rectangle, those slopes would be perpendicular, opposite, reciprocal. So it's not a rectangle, so it's not going to be a square. Could it be a rhombus? Might be. Let's check, see if it's a rhombus. And really, does everybody understand how I can use my slope to find distance? I'm going to show you on this one here. Actually, we'll show you on this one how you can actually use slope to find distance. To find the distance from this point to this point, draw yourself a right triangle. Count boxes, we already have. Rise 6, rand 7. To find distance, you're going to do a squared plus b squared equals c squared. So c squared will equal 6 squared plus 7 squared. Take the square root of it. I think that's root 85. So this one's root 85. This one's root 85. What about these? 9 and 2. A squared plus b squared. 9 squared plus 2 squared gives you 85 again, doesn't it? 9 squared is 81. 2 squared is 4. 81 and 4 is 85. So this would also be root 85. This is a rhombus. Can't get any more exact than that because it's not a square. Okay, so is it a parallelogram? If it is a rectangular rhombus. If it is it a square? If it is both rectangle and rhombus, it would be a square. That was number 15. Number 16, more of the same. First off, we know it's quadrilateral. It's got 4 sides. Then we ask ourselves, is it a parallelogram? And we know there's several different ways that we can find out is it a parallelogram. You can check, see if opposite sides are parallel. You can check, see if opposite sides, if you would like the distance from one of them, is opposite sides congruent. You can check to see one side, is it both parallel and congruent, one set. You can check your diagonals, if the diagonals bisect each other. The way you do that is find this midpoint. Find this midpoint. If the midpoints are the same, it is a parallelogram. And the last way involves angles, so we're not going to go there. You'd have to use some trigonometry to find angles. Let's stay away from that one. So let's check for slope. Rise 1, 2. Well, you could actually just look at the points. From negative 3 up to 0, that's a rise of 3. From negative 6 over to 5, that's going to be a run of 11. How do you get from negative 6 to positive 5, right? Let's do these two. From negative 11 up to 0, that's a rise of 11. From 8 to 5, that's a run of negative 3. That's a negative slope. Negative 14 to negative 3, that's going to be a rise of 11 and a run of negative, let's see, negative 6 to negative 3 and negative 6, that's a difference of 3, so that's also negative 11 thirds. From negative 14 to negative 11, rise of 3. Negative 3 over to 8 would be a run of 11. So opposite sides are parallel, so we at least have a parallelogram. The slope's going to be the easiest way to go here because now we can actually see too, do I have perpendicular lines? It's pretty obvious, isn't it? Negative 11/3, positive 3/11, those are perpendicular. Since it's a parallelogram, do I have to check them all for perpendicular? No. If it's a parallelogram, if there's one right angle, there will be 4 right angles. Also, let's see if it's a square or a rhombus. If it's a rhombus, then all of these lengths will be the same. Look at the slopes, guys. If you draw this right triangle to check to see distance, this is 3, this is 11. When you do Pythagorean theorem, you're going to get 3 squared plus 11 squared equals c squared. That's 9, 121. You're going to get root 130. But think, draw all these triangles, you get 11s and 3s, 11s and 3s, 11s and 3s. It's going to be the same thing. Okay, you don't have to test all 4. So this would be a parallelogram, because opposite sides are parallel. It was a square, or excuse me, it was a rectangle because these were perpendicular. It was a rhombus because all 4 are the same. And since it is a rectangle and a rhombus, it is a square. 17 says, which is not a method of proving a quadrilateral is a parallelogram? Quadrilateral is a parallelogram. 2 sets of opposite sides parallel. Diagonals are perpendicular. Diagonals bisect, or 2 sets of opposite sides that are congruent. Your answer is B. Diagonals being perpendicular has nothing to do with a parallelogram. If the diagonals are perpendicular, that would be a rhombus. Thank you. Number 18, which of the following cannot be used by proving or when proving a quadrilateral is a rectangle? I do want to point out that D must be proven first. You must first prove that you have a parallelogram. Before you can prove that you have a rectangle, D is essential. Okay, which other ones do you not use? The diagonals are congruent, there's one right angle, or the diagonals are perpendicular. Goes along with the last problem. Diagonals are perpendicular has nothing to do with a rectangle. That's a rhombus. Number 19, the sum of the interior angles of a convex octagon. Convex octagon. 8 sides, 6 triangles. That's 1080. Since there are, well, that's done. Never mind. B. I was finding each angle. Number 20 says each interior angle, that was B, each interior angle of a regular heptagon. 7 sides, 5 triangles. 900 total degrees, and there are 7 different angles. So each interior angle, 7 will go into 90, 12 times with 6 left over. 7 into 60 goes 8 times, that's 56 with 4 left over. 7 into 40 goes 5 times, that's 35 with 5 left over. 7 into 50 goes 7 times with 1 left over. So something like that. 128.571, which would be about 128.6 C. Number 21, each exterior angle. I like these. Tell me one more time, McKenna. The exterior angles will always add up to 360. No matter what the shape is, exterior angles always 360. Since it is a hexagon, each of them would equal, anybody, 60 degrees. And if they ask you, each interior would therefore equal the rest of it, 120. So answer C there. The side length of a square is 4 inches. What is the length of its diagonals? That one's fast. Which one? D. If you have a square, side length is 4. The side length also 4. Everyone can, thanks. Draw the diagonal. Thank you, ma'am. If this is 45 degrees and this is 45 degrees, you have a 45, 45, 90 right triangle. Shortcut to go from leg to hypotenuse, simply multiply times root 2. So 4 root 2 is your answer there, D. Nearly finished. Okay, maybe not. 23. While I'm drawing this, Tirsa, line LH. You remember what LH is called there? Mid-segment. Good job. This right here, because they tell you that this is congruent to this is congruent to this is a mid-segment. It's telling you that the mid-segment is 15, the bottom is 18.2, and I gave you a shortcut for this. The long way of working it, the mid-segment is going to be the average of the two bases. If you average the two bases, add them, divide by 2, that's going to give you the length of the mid-segment. You can solve that by multiplying by 2, subtract 18.2, that's one way of working it. The easy way of working it. I just want to throw this word out there again. You've got an arithmetic sequence here. 18.2, 15, blank. Okay, you're counting down. To go from 18.2 to 15, you're subtracting how much? Good, so do it again and you get 11.8. Subtract 3.2, subtract 3.2, 11.8 should be your answer. Number 24, you have a kite. You're given this is 128 degrees, this is 72 degrees. Again, they give you, this is kite. Find the value of angle F. Now, somebody last block worked this problem a little bit different the other day. They took and actually split this. And when you split this, you're actually going to split the angle, because you see the symmetry there. It'll cut the angle perfectly in half. It would turn this, if you drew this would be 64 and 64. This would be 36 and 36. That's one way of working it. And then seeing what adds up to the 180. You got two triangles. Or, when you're dealing with a kite, since you do have that symmetry, these angles, they're going to be equal. These two angles add up to 200 degrees. All four of the angles should add up to, how many total degrees, Brandon? Since there's four angles, good. 360 total degrees. Subtract that, I'm left with 160 for a total of 80 degrees here and 80 degrees there. Here you go. On this problem, it's asking for ZY, the length here. They actually also tell you that this is 8 as well, which you really didn't need to know that because it's a kite. Anytime you're dealing with kites, you have that symmetry anyway. If that up there was 8, that down there would be 8. So how are we going to find X? Pythagorean theorem. The diagonals of a kite are perpendicular. So therefore, anytime you got perpendicular lines, you have Pythagorean theorem status. I really encourage you, I've never done this before, like what I've started showing y'all, but it makes things so much easier. I really encourage y'all to shrink that triangle before you do Pythagorean theorem and then blow it back up. Because instead of 8 and 24, shrink that down to what? 2 and 6 or 1 and 3. Divide them both by 8. Use Pythagorean theorem on 1 and 3. And then multiply it back by 8. Blow it back up. Here you have 1 plus 9, which is 10, equals c squared. So c is the square root of 10. Multiply it back by 8, and you get 8 root 10. That actually saves the whole having to simplify your radicals as well. That's pretty cool. I'm going to go out on a limb here and say if you reduce those triangles, I don't think you'll ever have to reduce a radical. I don't think. Had you done that the other way, just showing you, you would have got root 640. And you would have had to split that into the square root of 64 times the square root of 10, which would be 8 root 10. You got the same answer. It's just much easier, much quicker that way. You weren't asked for it, but what if I ask you for this leg? That'd be a whole lot easier. Anybody tell me what it is? That's a 3, 4, 5 right triangle, is it not? 6, 8, 10. Yeah, reduce that down to 3, 4, 5, and then multiply it back out to 6, 8, and y would be 10. Could I ask you for angles on this? Sure. What if I want to know this angle here? You have a right triangle. The 8 would be your, hang on, cat. Opposite, adjacent, or hypotenuse. Well, if I'm looking for this angle, let's call it Z. The 8 would be your to it. So cat, the 8 would be the opposite, and the 24 would be the adjacent. TOA. Opposite, adjacent. Tangent. The tangent of your angle equals opposite over adjacent. Again, the reason I'm throwing so much more of this at you, normally I don't. Normally after that chapter 5, 6, whichever when it was, usually after it's gone, I don't mention a whole lot more about sine, cosine, tangent. We struggle a little bit with this chapter, so that's the reason we're throwing more at you, right? So tangent of z equals 8 over 24. Simply move tangent over and type into your calculator inverse tangent of 8 over 24. Has anybody got it? So we'll call it about 18 degrees. Good. If that's 18 degrees, now you know them all. That's 18 degrees. You have a right triangle. That leaves you with 72 degrees. This would be 72 degrees. That's a right triangle there. Now let's see, how could we, is there any way without using sine, cosine, tangent again, I could find one of these angles? I don't think there is. But again, sine, cosine, tangent is pretty easy. We'll call this one R, since I'm running out of letters. If I'm looking for this angle R, let's do opposite adjacent again. Opposite's 8, adjacent 6. That's another tangent. The tangent of R equals opposite over adjacent. So now you type in your calculator the inverse tangent of 8 over 6. And you get what? 53. So 53 degrees there. Symmetry, 53 degrees there. 37 degrees there. 37 degrees there. On number 26, it says find the value of x. We're talking about exterior angles. Remind me again, Thaxton, I think you were here for this one. When you're talking about the exterior angles, they all have to add up to what? Good. So you have 6x minus 5. You know what? I don't want to write all these down. You probably don't either, right? So what do we do? So we're going to add them up anyway. So why not add them up as we're writing them down? You have 3x, 2x, 5x, 2x, 6x. A total of 18x, thank you. And you have plus 10 minus 5, which is plus 0. And that has to equal 360, so x is 20. So your angles are 3 times 20 plus 10, which is 70. Well, we don't need the angles. You could add them up just to check yourself, but x is 20. That'd be an answer of B. Number 27. You are given an isosceles trapezoid. You have the diagonals drawn. Again, it is isosceles. XZ, which is this diagonal, would be 18. Since it's isosceles, this diagonal would also be 18. PY is 3. Let's go ahead and put 3 and 3. Remember the symmetry. If the whole thing's 18, that leaves you with 15 and 15. Everybody okay with that? I think that pretty much answered the question. What is PW, which would be 15? The whole thing was 18. They gave you this part was 3. So that rest of it, segment addition partial, I believe is what it was called. If the whole segment is 18, small segment is 3, subtract to get the other segment. Number 28 says find the value of angle D. Given a parallelogram. And I don't think we could find any angles on that last one. That's the reason I didn't go into it. We're looking for this angle, D. Given that this is 2y, this is x minus 5, and this is 2x plus 11. I think I worked this one for you yesterday. Since it's a parallelogram, even though it doesn't look like one, these two angles should be what? Equal? Supplementary, thank you. Adds up to 180. X and 2x gives you 3x. Minus 5 and plus 11 is plus 6. Let's go ahead and move the plus 6 over there by subtracting. Divide by 3, you get 58. But that's not what they ask you for. We have to plug it back in. If x is 58, that gives you a 53 degree angle here. It gives you a 127 degree angle here. This figure is not drawn to scale. That was what was throwing some people off. It's like, I don't think that's 53. It is. Since it's, and you're looking for this angle. Since it is a parallelogram, this angle is equal to this angle. So 53 degrees. Number 29, can we prove that this quadrilateral is a parallelogram? What do y'all think? Yes, you can. If one pair of opposite sides are both parallel and congruent, it is a parallelogram. So, what about this one? If I tell you that these are 3 and these are parallel, can you say that that is a parallelogram? No. No, you can't. Because when I say one pair of opposite parallel sides that are congruent, it has to be the same set of sides. And as weird as what I'm about to say is going to sound, it's true. That could be a trapezoid. It would be an isosceles trapezoid. Can you picture that? If you have 2 lines that are parallel, that's all you're given. These 2 lines are parallel, and the sides across from each other are congruent. It doesn't say anything about the lengths of these. That could be an isosceles trapezoid. Number 30, can you prove that this is a parallelogram? No, you can't. The other ways to prove that you have a parallelogram is if both diagonals bisect each other, which you only have one set there, or both sets of opposite sides are congruent. Or one set is congruent and parallel. Okay, the more I think about it, some people on this test just go simply by the looks of the shape. I might give you one like this, just to make sure that you know your properties. And I say, is this a parallelogram? You would tell me, yes. If opposite sides are parallel, even if they don't look parallel, if opposite sides are parallel, that is a parallelogram. If I told you that this was true, would that be a parallelogram? Yes. What about this now? If I ask you what shape that is, right? Now we all of a sudden, well, it'd be nice, well, before we could guess, because, well, it looked like a parallelogram, or it looked like a rectangle, or it looked like this or that. Somebody want to share with me what shape this is? That is a rhombus. Good job. The rule is, first check and see, is it a parallelogram? This is a parallelogram. It doesn't look like one. If opposite sides are both parallel and congruent, it is a parallelogram. Then let's go a step further and say, okay, is it a special type parallelogram? If you have a parallelogram and the diagonals, they don't look like they do, but if the diagonals are perpendicular, then you have a rhombus. What about this one? Anything special there? That would just be a basic parallelogram. Diagonals bisect each other, that's a parallelogram. Okay, nothing special about it. What about this one now? Not only do the diagonals bisect each other, but does everybody notice that you have 2 tick marks around the house? You got, if this is 5, this is 5, this is 5, this is 5, that means the whole diagonal is 10, and this whole diagonal is 10. This is a rectangle. If the diagonals are congruent, then you have a rectangle. So please know the properties well enough to where if I gave you a really weird shape, and I tell you that these things are true, then you can still, you still know what type of shape it is.